We have learnt equality of two polynomials. Now, let us use it to find two or more unknown coefficients in a polynomial. These two polynomials are equal. How can we find the unknown values of a and b? We learnt that we can compare coefficients of terms, or substitute different x values if two polynomials are equal. Let's use the comparison method. We use the principle that when two polynomials are equal, their expressions are identical. To make the expressions identical, we just need to expand q of x and group the like terms. Now, we are ready to compare the coefficients of the terms. Let us compare the coefficients of the terms in x squared. What can you say about the value of a? We can see that a is equal to 7. Next, comparing coefficients of the terms in x, what do you obtain? It is b plus 2 times a equals 17. Since we know the value of a is 7, the value of b is 3. We can also use the substitution method to find the values of a and b. This is because p of x is equal to q of x for all values of x. We can therefore form this equation. Now, what value should we substitute for x? Look at q of x in particular. The factorized terms x minus 3, x plus 1, and 3 minus x. They tell us that we can try x equals 3 or x equals negative 1 for the substitution. Let's first try x equals 3. What do you notice? P of 3 and Q of 3 are both 0, so we cannot find the values of a or b. Next, let's try x equals negative 1. This time, the term involving a becomes 0. From the equation, we can find the value of b. So, in general, substitution method is useful when one of the polynomials is expressed in the product form just like q of x. Let's look at another example. Here are two polynomials and they are equal. How can we find the three unknown values of a, b, and c? Remember, we have used either comparing coefficients of terms or substituting values of x before. But in this example, we will show how we can use both methods, comparison first and then substitution. So let's look closely at g of x. Without expanding g of x, we can see that the coefficient of x squared in g of x is a. Since the polynomials are equal, the coefficients of the terms must be equal. Now, compare with the coefficient of x squared in h of x. What is the value of a? Yes, a equals 2. Since g of x equals h of x, we can equate them. Now, look at the term c times x. We can find the value of b by substituting x equals 0 in the equation. The value of b is 4. Now we know a equals 2 and b equals 4, and we can form an equation using g of x equals h of x. We can find the value of c by substituting x a suitable value. Which is the best value? Look at the term x minus 1 in g of x. So we can substitute x by 1. From the equation, we can find the value of c.